Welcome everybody to Glow Your Own Session 4. The festival has ended, but Glow Your Own still continues for another couple of weeks while we build and design and make some exciting lanterns. So we'll today be working on ways of adding new different types of control. And as usual, we've got Sophie doing coding and Sarah with our troubleshooting, and we've got Kate back, and we've got a new person, Janida, who's in the room. So Janida is someone who works with apprentices. So perhaps, Janida, if you could just say hello and just say what you do.
Yeah, hi everyone. So I work at Oxford Advanced Skills. So we do engineering apprenticeships, so level 3 and level 4 apprenticeships. And I'm the ED&I and STEM ambassador. So I go to schools and tell them about what apprenticeships are and what engineering is as well.
So if you like this sort of thing and one day you want to become an engineer, engineering apprenticeships is one way of moving into an engineering career. So enough of that. I'm going to pass right on to Sophie and we can get on with some tinkering and coding. How about that?
Works for me. Hello, everybody. It's lovely to see you all again. And if you do have any questions about apprenticeships, I'm sure Janita would be really happy to answer them in the chat. We have lots and lots of apprentices at the big lab that I work at, and lots of people who used to be apprentices and now work on our big experiments and stuff. So it's a really cool thing to do. All right, so today, like Dane said, we are going to be using some different types of controls to control our circuits. We are going to be using a new type of sensor, something that looks at the environment around us and turns a light on, not when a button is pressed, but when it gets too dark. So when it's dark, the light is on, and when it's bright, the light turns off. Because sometimes, if you're like me, you're just too lazy to get up and turn a button on and off. You want it to happen automatically with the light. And it's not lazy, it's just conserving energy. That's a good way of putting it, isn't it? All right, so like normal, I will share my screen and we're going to do it all on Tinkercad first. So we'll make our circuits and we'll test them out. We'll test our code out online, and then we will move to our real circuits in real life. Okay? Okay, so let me just share my screen with you. So in the chat, there should be the link to the Tinkercad classroom. So you've all got this, and then we click join with nickname. And my nickname is GYO Sophie, because I'm not good at remembering numbers, so I gave myself a special nickname. And then we get to our Tinkercad, and here you'll see the circuits that we've made over the last 3 sessions. So we've got the getting started one where we made a light, the real Arduino where we turned it into a real physical circuit, and last week's where we used a button. But we're going to create a new one. So we're going to go up here to create and then create circuit. Then have to be patient for a minute. We're going to get our Arduino out, our little microcontroller to give all our instructions, and our breadboard so that we can make our circuits. So our circuits are actually really quite like the circuit that we built last week using the button. So we're going to have a circuit that is a light, an LED, and then we're going to have a circuit, but instead of with the button, we're going to use something that measures the light around. So let's do the light circuit first. This is one that we've done before, but we'll just go through it so that everyone is at the same point. So we're going to go up and we're going to get our LED, our light emitting diode. We're going to pull it over and pop it on our circuit. Actually, I'm going to put it there. And I think today I'm not going to have a red light. I'm going to change my light to yellow. I think I'll have a yellow light today. And then I'm going to connect it up to my computer, to my Arduino. So I will have a wire going from my Arduino to one of the legs of my LED. like that. So I've gone from pin 2 this time. I'll just zoom in so you can see a bit better. Pin 2 up to this leg that's a bit at an angle. And then I'm going to get a resistor. That's going to go from the other leg. And remember, for a light, we're going to change this resistor to a smaller value. So I'm going to call it 220 ohms. All right, so our circuit is nearly complete, goes up through the wire, through the LED, through the light, and then we're going to go back to ground, down like this. Okay, I'm going to change that color, brown. So that is the circuit that we have made every time for the last 3 ones. You're really good at making this circuit. Well done, everyone. And now we're going to do the next part. So this is like what we were doing last time, but instead of using a button to control our light, we are going to use what is called and I've lost it, where is it? A photoresistor. Sometimes it's called an LDR or a light dependent resistor. So if you move down on your components, you can see this one that's called that says a photoresistor. It's a circle with a squiggly line in it. And so you click on that, and then we're going to pull it over to our breadboard over here, like this. Now, what a photoresistor is it's a resistor just like the resistor that we've got in this circuit here for our LED, but the value of the resistor, its strength, changes depending on how light it is, on how much light this photoresistor can see. And that means we've got a measure of how light it is, which means that we can get the Arduino to say light turn on if it's dark and light turn off if it's nice and bright. Okay, does that make sense? So once we've got that, we need to connect our light dependent resistor or our photoresistor up to the Arduino so that we can read the value in that it's doing. So it's really very similar to the button. It needs some power, just like the button needed some power. And you'll remember that when we did power, what we did was we went from one of the legs, we made a wire from there down to the red line on our breadboard. I'm going to make that a red wire. And then we connected that red line to the power supply here on the Arduino. So the one that says 5 volts. I'm going to go down like this, along like this, and up like this. And then I'm going to move that so it's nice and straight. So our resistor is now connected to the power. And so it's got all of the power that it will need to run. But you will notice that there is a problem because it's not a complete circuit, is it? We go from here, the Arduino, through this red wire to the red line, along the red line, up to this wire, up here to the resistor, but then it doesn't have anywhere to go, does it? So we need to complete our circuit, and we need to put one more component in to do that, which is a resistor. Just like with the button, we're going to put a resistor in. So go up to this resistor, and we're going to complete it like this. So from the other leg of the photoresistor, we're going to go from there to the blue line or the black line. And the value for that resistor should be about 1 kilo ohm, just like the button, in fact. All right, now I did that quite quickly. So how are you doing? Do you have that circuit ready? Give me a thumbs up or something. And remember, if that was a bit quick, don't worry, because we're recording this. You can pause me. You can watch the recording and pause, go back and test it out. Oh, fantastic. We've got some celebrating emojis. and we've got a thumbs up.
And a dodo.
Oh, a dodo. I still think it's a bit too early for Father Christmases. It was only Halloween yesterday.
But the hedgehog is always welcome.
A hedgehog's definitely always welcome. Love a hedgehog. Brilliant. Oh, honestly, you are so good, everyone, at your emojis. I can barely do the smiley face. I've had there's a really great question in the chat, which is what is the ohms for the LED? And Sarah has answered that because she's brilliant. It's 220 ohms. Doesn't have to be exactly 220 ohms. A couple of hundred is fine. Okay, so we actually have to include one more wire for this to be a useful circuit. So we do have a circuit that goes from the Arduino through the red wire, up through the red line on the breadboard, up through this red wire, through the photoresistor, through the other resistor, along the blue line, and then back to the wire into the Arduino. So it is complete, but it's kind of pointless because it's not telling us anything. So the photoresistor is saying, oh, I've got it's bright or it's dark, but it's not telling that information to the Arduino. So we're going to have one more wire that is going to go from our photoresistor back to the Arduino to send the information back. So we're going to go from here. So the line on the breadboard that goes from the photoresistor to the normal resistor, we're going to go from here and do a wire down to the Arduino, okay? But we're not going to use the pins that we've been using before that we use for the buttons. We're going to use pins on the other side of the Arduino that are called the analog pins. So all the way down here, all the way up here, there. And now I'm in the middle of my Zoom screen, and so I can't move. Sorry about that. To these pins at the bottom that are called analog in. So they're labeled A0, A1, A2, A3, A4, A5. And so we're going to send the information from the resistor, the photoresistor, to these analog pins. And because it's sending information in, I'm going to use a yellow wire for that. Now, the reason that we're using analog pins instead of digital pins is because the photoresistor sends different kinds of information. When you've got the button, when we had the button last week, we just wanted to know, is it pushed? Yes or no. There were only two answers that it could be. Either it was pushed or it wasn't pushed. But with the photoresistor, it could be, I'm really, really bright. I'm quite bright. I'm sort of okay bright. I'm a bit dark. I'm really dark. I'm 1,000 kilometers, I'm 1,000 meters under the ground in the Bulby Underground lab, and it's really, really, really dark. That's another one of our labs, which is really cool. I'll tell you about it another time. But it's very dark because it's 1 kilometer underground. So it could tell you all different values. And when you have all different values, then you want to use an analog pin. So is everyone okay with these? Has everyone finished their circuit? That is our circuit done. Now we just have to do our code. So pop something in the chat or make an emoji or something that says, oh, I love the penguin. I like penguins. So that I know that we're all ready for the next step. Oh, got a crazy face. Good job, everybody. Good job. Oh, there's a sparkly heart as well. I like it. All right. So now that we have our circuit made, we are going to write our code, our instructions for our Arduino. So you'll all remember we head over to the top right of the screen and hit the code button. And then we've got the bits that Tinkercad's like, oh, would you like this code? It really wants us to use this code, but this code is boring, so we're not going to use it. So I'm going to throw it away down into the bin on the right-hand side, or you can actually just put it over there, just like in Scratch. And we're going to use some code that is very similar to the code that we used for the button before. We're going to use an if then else command in our control. So we're going to get the control and we're going to have a forever loop, because we always want it. We don't want it to only happen once. We want it to happen forever and ever and ever, to always turn on if it's dark and always turn off if it's light. And then we're going to go down here and get an if then else block. Okay. All right, now I'm going to show you a new thing that is really cool, because if you're like me and you forget what you're doing, it's a way of writing yourself notes in your code to remind yourself what you're doing. So if you look over here at this notation block, there are these things called comments. And when you write really good code, the best code has lots of comments in it that explain what the code is doing. So for us, I'm going to put 2 comments in. I'm going to put one comment in that says, turn the light on if it's dark, and one comment that says, turn the light off if it's bright. We'll put them in the different areas to remind ourselves of which bit is which. So I'm going to bring this comment and put it here, because I'm going to say if it's dark, if it is dark, then light on. And then I'm going to do another comment saying if it is bright, light off. And that just means not only will you remember it, but also if anybody else, if you were to share your code with somebody else and they were going to use it to change it, they would then be able to understand what you were doing. That's really important for us, because it's hardly ever just one person writing code. We write code and instructions that is hundreds and hundreds of people all writing the same code and all using it. So you have to be really clear about what you're doing. Okay, so comments, really useful. I love comments. And sometimes people write sneaky little jokes in them. Let's see if you find them. That always pleases me. Okay, so we've got our if block and we know what we want to do in all of these things. But now we need to get what question we need to ask the Arduino. So the question that we want to ask the Arduino, is it bright? So is it brighter than a certain number? So we're going to use some maths. We're going to use is something greater than or less than, bigger than or smaller than, which is this triangle one here. So we're going to pull this in and plop it in there. Okay. So at the moment it says if 1 is less than 1, which isn't very helpful. But what we want to do is if the reading from our photoresistor is less than a certain value, then we want to turn the light on. Now you can get the input, the reading from your photoresistor, the same way that we got the reading from our button. So you can go to input here, this purple one, but instead of using read digital pin like we did before with the button, we're going to read the analog pin here. So put that there. I'm just going to make it slightly bigger so you can see all of it. So if the analog pin, now my pin is not A0, my pin is A1. So just like with the other ones, we can change that to the one that my wire is connected to. Okay, now just for now, I'm going to put a number in here that's just 300. Now, this resistor will send a number back to the Arduino, and if it's really bright, it'll be a certain number, and if it's really dark, it'll be a different number. So we're just going to compare it to a random number, okay? For now, so you can put it for 300 for now, and we'll talk about how we pick that number a little bit later.
So while people are catching up, I just noticed in the chat box, so Caitlin, who is an engineer, says some of the comments she comes across in her job, I'm not sure why this works, so please don't remove it. So comments are really useful for collaborating in teams, because if you're not sure if it works and it's not clear straight away, sometimes if someone goes, this is a really good piece of code, don't accidentally take it out.
Yeah.
That's a good one to keep.
I do like that. My favorite comment that I've ever found in a piece of physics code was, I think this breaks the laws of physics, but the code doesn't work if I take it out. Slightly worrying, but it was fun anyway. Made me smile.
I think lots of people have got lots of, we've got chickens, we've got hearts, we've got a ladybird supper, I think, possibly. We've got knives and forks and ladybirds. And I think possibly, yeah, I think we're ready.
Let's do our next two things. So the next two commands, the last two commands for this are, we want to turn our light on if it's dark. So just like before, we go to output, and we're going to set a pin to high if it's dark. And mine is connected to pin 2 over here. So we're going to connect that to pin 2. And I'm sorry, everyone, I've just realized that I've put things on the wrong screen. So it looks like I'm not looking at you, because I was looking at the wrong screen when I was doing my coding. So turn it on if it's dark, and if it's bright, turn it off. So set pin 2 to low. Okay. Now for the moment of truth, and the moment to remember if I have remembered if that's the right number or not, because I can't, I guessed a bit. It's okay if it doesn't work the first time. Normally doesn't work the first time. We're going to simulate it. So remember, this is asking the question, is it dark? If it is dark, it turns my light on. If it's not dark, it turns my light off. Okay, let's start the simulation. Initializing, stop simulation. So my light is on, so my LED thinks it's dark, apparently. Now you see, if you click on the LED, or if I move it down a bit, you'll be able to see it more clearly. If you click on the LED when you're running a simulation, you'll see that this little slider comes up. And this is how you pretend if it's dark or bright. So you can see now the slider button thing is right at the dark side, so it thinks it's really dark, and my light is on. Hooray, that's great. But if I move it up like this, you'll see, oh, it's got brighter, and so my light has turned off. So if I make it dark, my light is on, and if I turn it up, make it brighter, then my light is off. Which means I picked a number that was kind of right. Hooray, everyone. How's it going? Have you got it? Oh, Sarah had a thumbs up, so Sarah's is working. Good job, Sarah. How about the rest of you? Have you got lights that turn on and off when you slide it, make it brighter and darker? Kate has, brill. Lots of you have, fantastic. Okay, so I'm going to show you one more thing on our Tinkercad circuit before we start building the circuit in real life. Okay. And this is something that is really helpful when you're trying to figure out your code, figure out something that's working or something that's not working. And it is in the output. If you go down here, you'll see there's this command here that says print to serial monitor. And this is a way of the Arduino talking to you, basically. So it will print out something, and you can print out hello on your computer screen or something. Hello world is normally is one of the first things we get it to test out. You can print out useful things that tell you about your circuit. So we're going to get one of these, print serial monitor. We're going to pop it up here above the if loop, but within the forever loop. Okay. And instead of printing hello world, which is nice and polite, we are actually going to print what value our photoresistor is sending to it. Okay, so just like in our if statement here, we're going to go to input and put read analog pin. And then we're going to change that to A1. Okay. And so what this is going to do is it's going to print to the screen the value, the number that our photoresistor is sending to the Arduino. And you can find the serial monitor, which is where it prints it to, down here at the bottom of Tinkercad, kind of in the middle. So if you click on that, it brings a bit up, and then it will put the information there. Okay, so I'll just simulate it so you can see what happens. So if we start the simulation, you'll see that it's saying, oh, it's reading 6 at the moment. And if I move it, keep an eye on it, it goes from 70, and it goes up, we're making it brighter, and making it brighter again. It's getting brighter and brighter and brighter, super bright as the sun. So when it's as bright as it can be, it's sending me a number of 679. And if it's as dark as can be, so my light is on, it's sending a number of 6. Okay, and so that's really helpful because it means that we can figure out what number would be best to put in here to see whether it's bright or if it's dark. Okay, so if I wanted to turn my light on, say when it was in the middle, I could look here and say, oh, well, when it's in the middle, it's 526. So I'm going to stop my simulation. I'll change this to 500, like that. And then let's start again. And it's going dark and it stays brighter for longer. And now it's gone dark because it's more than 500. All right. How's it going, everyone? Have you got numbers here in your serial monitor? And have you managed to change this? Are the numbers the same as on mine? Because sometimes it can be different from different computers.
Excuse me.
So if you've got any questions, do pop them in the chat, and Sarah will be able to help you, or Kate will as well. Oh, we've got some of the same numbers. Great job, everyone. Oh, and a koala. Koalas are my best friend's favorite animal. Yeah, so this can be really, really helpful. And you can use it with real Arduinos as well. And Duino or the Arduino app will print them out as well. Okay, so, oh, Kathy's got it. Hooray for Kathy. Well done, Kathy. You just sounded so pleased. All right, so any questions, just pop them in the chat, or we can talk in the troubleshooting bit at the end, okay? All right. Okay then, so I'm going to stop my simulation and I'm going to move the serial monitor back down a bit so that we can see more of the code. Okay, now what we're going to do next is we are going to make the circuit in real life, just like we've done in the past 2 sessions. Now, remember, before we do that, remember you've got lots of little small components, and we don't want anyone to step on them, or we don't want them to fall on the floor. So please do make sure that you keep them on your desk. They're nice and tidy, and do check around on the floor where they're nowhere that like little children or pets or people can get to them. Okay. And the other thing that we're going to remember is only to put things in or take things out if our circuit is not powered. So if our circuit is not connected to the Arduino. Okay, so if we want to change anything, we're going to unplug it, change it, and then plug it back in. Okay. All right, so I'm going to stop sharing my screen. Now I've tried to make a little tower for my Arduino cam so that it can look at it a bit more easily, but I might have to pick it up and show you in more detail later on. Okay, so and I realized I should put it the other way around so that it matches what's on the circuit, shouldn't I, on Tinkercad. Right, so maybe I'm going to hold it because this is the other orientation, isn't it? And I'm not going to be able to cope with that. So let's see. Here you go. So we've got our Arduino and we've got our circuit board, our breadboard. Okay, so we're going to build the LED circuit first. You can have a look at your Tinkercad circuit to follow along with those to make sure that your real circuit looks like your Tinkercad circuit. So first, going to get our light, our LED. And you'll remember that one of the legs of our LED is longer than the other. And the short leg is the one that we want to be closest to the ground. So you put the short leg on the left-hand side, and I'm just plugging it in there. Okay, so I've got my LED plugged in. Then I'm going to connect it to pin 2, just like on my circuit. So let's go down here to pin 2. There we go, that's one end. Then connect my circuit in over here. There. I'm sorry if you see me sticking my tongue out. I'm not sticking my tongue out at you. It's just fiddly and sometimes it helps me concentrate. Dane's laughing at me, but that's okay. All right. Now we need our resistor. And now this should be a resistor that is just a couple of 100 ohms. So it could be 100, 200, 220. I'm going to use one that's 330. Just trying to untangle it because my resistors have got all tangled up. I've got my resistor and I'm going to plug it in so that it goes from the left leg of my LED over here. Oh, but it's being a bit fiddly today. Sorry, I'm all juddery, aren't I? Might have to put my phone down so that you can see it properly in a second. All right, let's try this. Just for a second, I'll put the phone down so that I can hold this properly. So that goes into that one. There we go. And then it goes next to the blue line, down like that. Okay. So you can see you're probably much speedier than this than I am at the moment because that took me ages to get that in. And then the final bit for this circuit is we're going to go from the blue line over here to the ground on the Arduino. So any one of the ones that says GND. Oh. Like that. Okay, so that's one circuit. And now we're going to use our photoresistor. So you'll find your photoresistor in your Tinkercad pack. It's got really long legs, like this, longer than the LED normally, and it's a little circle, or sometimes like a squished circle. And on the top of it, you can just about see on this, it's got a pattern of wiggly lines on the top, so you know it's a photoresistor. So yeah, that's the one that we're going to use next, and that is what we're going to pop in. So let's pop it in 1 hole and 2 holes like that. I'm going to have to put Arduino cam on its side for a second so I can pop it in properly. There you go. There. So now that's in. over there. And then we're going to connect it to our Arduino. So we're going to put some power in. So I'm going to get a wire and go from one leg of my photoresistor to the red line here. And then I'm going to get from the red line to the power, the one that says 5V on my Arduino. So let's go from this red line here all the way over here to the one that says 5V. Oh, move that there so you can see a bit more clearly. 5V. All right, so how's it going, everybody? We've got one complete circuit and one circuit that we're half done. With. Let me see. All right, so this is what it looks like, everyone. Okay, so you can see this is a photo of the photoresistor. So you see it's got these long legs. It's like a squished circle, and then it's got a wibbly line on the top. Like
really tiny, everyone, really small, like about the same size as the other resistors, really, so they have to really dig in your box to try and find it.
Yeah, so yeah, this is what it looks like. It's got long legs, so it's the tallest thing on my circuit at the moment, apart from the wires. So you can see on Tinkercad my photoresistor is on the breadboard across two of the rows over here next to the LED. And then if I stop sharing, I will show you on my circuits in real life. Now let's spotlight Arduino cam. Let's go down like this. So you can see here is my LED. Just give it a second to focus. And then next to it, I've got my photoresistor, the big tall one, which is here. And it's connected, and so far I've got two wires. It's connected to the power. Okay, my legs are a bit wobbly. Your legs will probably be nice and straight for your resistor, your photoresistor.
We've got some eagle eyes, which has spotted you're missing a 1 kilo ohm resistor going from your leg.
Oh, you are brilliant, everybody. I am indeed missing a resistor. You're the best. All right, so as you've so rightly pointed out, I need to pop a resistor in. This is a 1 kilo ohm resistor. Oh, sorry. And I'm going to pop Arduino cam up on here steadily. Oh. Except I've clearly put it in a slightly different place, and so you can't see it properly.
Oh, that's perfect.
There you go. And then I'm going to put my resistor in. So one of the legs of my resistor goes in the same row as one of the legs of my photoresistor. So along here. Sometimes you've got to just be a bit patient when you're putting your resistors in, because it's easy to scrunch the wires up. And then the other leg of my resistor goes to the blue line, the ground line there. Okay, so now you can see I've got a complete circuit, because I go from the red line, which is connected to the power down here, goes up through my photoresistor, through the normal resistor, to this orange wire, which goes to the ground on my Arduino. Okay, but there is one extra wire that I need to do. What's that extra wire? Anyone? You are so good at spotting the resistor. Any ideas? 5 volts, good point. Yes, A1. So the 5 volts is this red wire that's going from power over to 5 volts here. So I've got that one, but I need the one that goes to pin A1, the analog input. So you remember this goes on the same row as the row of the resistor and the photoresistor. So I'm going to pop that in there like that. See, that's all on the same row. And then it goes to pin A1, which is just there. I think, yes, that's pin A1. Can be quite tricky to spot to get to the right one. I find it quite tricky to find the right one. And then we have our circuit all completed, which is amazing. Well done, everybody. Give me a wave or something when you're finished doing that, and then we'll do the final step. Oh, a lovely parrot. I like the parrot. And a thumbs up. Brilliant, everyone. Like I said, don't worry if you're not quite there yet, because this is all on, all being recorded, and we can do it. And so you can watch it on the recording later. That's not a very helpful place to leave it, is it? There we go. You can watch it on the recording later. Awesome. All right, so I'm going to switch back to sharing my screen now, so that we can do the final step, which is sending our code, our instructions to our real Arduino. Okay, so let's share my screen. Now this is exactly the same as we have been doing for the last couple of weeks. It's also the bit that sometimes your computer's just being a bit grumpy about it. So it is the bit that we need a lot of patience to do. Always need a lot of patience and to persevere when you're doing coding. So the first step is to go from this that says blocks at the top to the left of the code, and change that to blocks plus text like that. And then we've got the different values, the different language. So we're going to highlight all of this and then copy it. So do Control C like that. Okay. Then we're going to go to the Duino app, and maybe Sarah or Caitlin, you could pop the link in the chat for everybody as well. And we're going to do some code because that's what we like to do. So that's at the top left. You press the code button here, and we're going to create a new project. I'm going to call it GYO session 4. And then we're going to create.
Before we get too much further, can I just, we had a few errors last week, and one of the things that we realized was that you have to create a new project every time. Make sure you don't open an old one and add a new file. We need to make a new project that will help stop some of the errors that we might be getting.
That is good remembering, Sarah, because I had forgotten about that. So thank you very much. Okay, so once you've created a new project, we're going to delete the code that Duino says, do you want to do this? Because we don't want to do that. And then we're going to paste our code from Tinkercad into this. So I'm going to do Control and then V. And there is the code that we wrote to send to our Arduino. Okay, now I'm going to plug my Arduino in. So I realized I forgot to do that, and it definitely won't work if I don't plug it in. There we go. My computer's made a ding dong noise to say, oh, something's attached to me. And then we go down here to the bottom on the right to press select device, so that this is telling the computer what to send it to. So you do select device, and then it says, I want to connect. Now, unfortunately, each computer calls things different things. And so for me, I'm going to click to this USB serial device. Sometimes it says Arduino in there. Sometimes it says other things, but USB serial device or Arduino are the most common ones. So click that and then click connect. And then you'll see down here at the bottom, it says serial selected. Okay. And now for the moment of truth, we're going to send our code to the Arduino. So you'll remember that up here on the top, on the right-hand side, there are these little buttons. One of them is the serial monitor, it says serial. So you could click that and see the numbers that it comes up with. So I'm going to do that just so that we can see. So you'll see here you can do monitor if you wanted. So I'll put that down for a sec. And then I'm going to send it. So remember, it's this middle one, the square with the triangle in the middle that says compile and upload. So I'm going to click this, send it there. It's uploading, it's sending it, and it's done. My light is on. And let me see if I can make it turn off. And there, I've got my torch on there, and my light has turned off. Oh, but you didn't see. There you see, my torch is on and the light is off. And I move it away and my light turns on. All right, so I think that is about all we've got time for. So I hope you managed to do that. Fantastic work, everybody. But like I said, don't worry. We did go quite quickly through that one and it's a whole brand new stuff. So I'm going to hand over to Dane, but well done, everybody. You did amazingly. That was a whole bunch of new stuff. You should feel very proud of yourselves. Well done.
Great. Thanks, Sophie. And it was so good to see all the success happening in the chat. There was a little bit of difficulty in there, and Sarah and Kate and Janita were really helpful in fixing things up. So I was following it along and made my work too. And one of the things, because I'm a little bit lazy, one of the things that you might want to think about doing is if you change the value of the sensitivity of your light-dependent resistor in Tinkercad, you'll notice when you get your code, there's a little, it will say analog read and then pin, for instance, A1, and then the number that you've put in Tinkercad is in the bracket in your code. And if you want to just change the value depending on how bright or how dark your room is, you can just change that value sort of on the fly rather than having to do it all the way in Tinkercad. So you can manipulate the code directly in the Duino.app. So I was just doing that and I've managed to make mine work too. So when it's, I don't know why it's flashing, I think there's a loose wire or something going. When it's too bright, it's off, and when I cover it up, or if I it'll start flashing. I think I've got a loose wire somewhere in there, but I was just doing that on the fly, so you might find that that's a fun thing for you to play with once you've got your code working. Thanks everyone for coming, and we'll do more stuff next time. Next time we're going to be doing some making, so we're going to be doing making some lantern houses and crafting. It's been great, so we'll see you all next time for Glow Your Own. Have a good time coding. Bye.
Bye everyone.